Modeling data with exponential functions. The purpose of this lesson is for you to realize that exponential functions are pretty much a function of daily life. This does happen in real life, and it is important for us to understand them. And not only from a mathematical point of view, but from a philosophical point of view, just a lot of things that really apply to your real life about understanding what the exponential functions work out. If the most practical way, it's money wise, like debt, investment, all the stuff happens exponentially. So whether you like it or not, your mortgages, everything has to do with this. So we got to understand it to make a better use of our thing. So let me start with a very kind of silly perhaps, but hopefully a little bit entertaining example. So let's say we got this, an interesting proposal. Your eccentric rich uncle, this is a pretend situation, has offered you to give you a lot of cash since you are doing so well in math. So I told you it was a pretend situation. What? Burn! All right, it's more fun when you get a reaction live. So this rich uncle gives you two options. Option number one is to take $10,000 every day for 30 days. That seems pretty good. You would get, well, 30 times 10 is how much? $300,000. And the other option is to take a penny today, then 2 pennies tomorrow, then 4 pennies the next day, 8 cents the next day, and so on for 30 days. So then I would ask the class, okay, which choice would you take? Choice A or choice B? And then you get a split. So people say okay, no, Ashi, okay, go ahead. Pick which one you want to get. If you need to stop the video, stop. So what usually happens in class is people say, well, $300,000 for sure. Why would I want to get the pennies? That's what one people think. And then people say all right, this seems so one-sided that it seems like somehow the pennies would end up being better. So some people pick the A and some people pick B. The people that I pick B, I said, all right, so your uncle challenges you one more time. So would you take $1 million or the pennies? And now it's a bit harder to figure out, okay, is it good? Is it not good? But try to guess. You're just guessing right now. We're just trying to get an idea. So I read this on a book, and then in the story in the book, there was a little cash that the uncle had instructed some people to put the money in, and the people would come in and pick up the $10,000, stuff like that. So this is what would have happened. Make it a little bigger. So after the first day, 5 days, after the 5th day, well, your brother, let's call it your brother that picked up the $10,000, he's got $50,000, and you got 31 cents. So you got 16 cents that day, but 31 cents kind of all together. So that's not so bad. Actually, that is pretty bad. So let's go 10 days. Under 10 days, you already picked up 10 bucks. You got a full $10. That's pretty good. But your bro's got $300,000. Your brother comes to you brother, just go, sister, go talk to your uncle. Just maybe he can still let you switch. This is crazy. Look how much stuff he's driving, his new car, and you're 10 bucks in your wallet. Halfway through the month, things got a little bit better, and you got a total of $327. Your brother's got $150,000, which is still going like you're crazy. So what happens next? So I go to the next page, and well, on day 16. You got $655 on day 17. You broke $1,000. And it's just really good because you only have let's see. You've got 10 days left. On day number 20, you just broke $10,000, which is good money, but it's what your brother got in the first day. So this is not looking so good, or is it? Things are increasing more and more, right? Now it goes to 20, then to 20, 40, 42 almost. Then 84 almost, and on day 24, you break 167. Now, that's pretty darn good, but on day 25 is when the magic happens. You got 335, and as you remember, your brother on 30 days is gonna get $300,000. So it waited, and then it picked up really fast, and on day 25, you already got more. But the good news is that you got 5 more days to double and double and double. And you're not going to believe this. Keep on looking at those numbers. 28, 29, And on the 30th day, you would collect $10.7 million by just doubling a penny every day. Now, I usually just ask people, okay, so what would that be if we divide that by 30? That would have been like almost $358,000 per day to get that same amount of money. So clearly, doing this was better. Now, of course, this is not like a real situation. This is not a real situation whatsoever, but it kind of helps you figure out a point. So here's the graph of the whole situation. The whole situation will look something like this. The graph looks very, very flat for the longest of times, and then it just picks up, or seems to be picking up right away. Now, this is getting increasing and increasing the steepness, even though we can't quite see it because of the scale, and then it becomes very evident. And this is kind of what happens with a lot of things. It happens with our investments. A lot of people put in their money in for a long time, and they see, oh, there's no return, there's no return. Forget this, I'm going on a holiday. Forget this, I'm buying that big screen TV. And then they miss out on this thing happening. Now with this shape, it's kind of crazy because we are getting double the amount of return every day. Now that does not happen. But in a lower scale, if you can zoom in, then you still can do the same thing. The longer you can stay on an investment, the longer you can stay on things like this, well, the more money you're going to make in the end. So you got to be patient. Now, the reverse happens too. When you're borrowing money, like on a mortgage, the longer you take in paying back a mortgage, well, the more interest you're going to be paying. And it gets kind of painfully big as time goes by. But we'll get into that a little bit later on. Let me continue on. I was going to break it up. There's another example here if we say, okay, hold on. One main point is like this goes flat and then it kind of takes off, right? It could be a lot smoother, but that's kind of the idea. If we did an example like this one, when we say, I get a whole bunch of dice and I start rolling them. Every time I rolled a 1, I will remove that die. So I'm going to end up with this many die, and then I will lose some dice, and then I will lose a little less. Oh, let's try that again. I would lose some more, then I would lose some more, then I would lose some more. But then little by little, I get less and less, and it gets flatter and flatter. And you get a shape like this, which seems to be going in the opposite direction of the other one. And that's also an exponential function that's going to happen. Like it drops faster, and then it starts dropping less and less. It's kind of like the temperature on a coffee cup. If I do paper cutting, so if I get a piece of paper and I cut it in no pieces, then I would have just like 1 square. If I fold it and I open it up again, I'm gonna see 2 pieces. If I fold it again, I'm gonna see 4 pieces. If I fold it again, I'm gonna get 8 pieces. Then I'm gonna get 16. Then I'm gonna get 32. Then I'm going to get 64, etc., etc. And as you can see, the shape is, again, it starts kind of flattish, and then it gets steeper and steeper as it goes up and up. Make sense? So it's another show of an exponential function. So here are the main points for this lesson, really. Many real-world situations can be modeled using an exponential relation. To check whether a relation is exponential, check if the first differences have the same ratio. Okay, what does that mean? Let's go back here. So if the thing was 2, 4, 8, 16, 32, first we got to check the first differences. The first difference here, it goes from 2 to 4, it goes up by 2, up by 4, up by 8, up by 16. And a very interesting thing happens is like my first differences are the same as my y values. This only happened because it started at kind of like at 1 and then it went up to 2. Okay, if it didn't start at 1, that would not happen. But that's kind of interesting. Now, I need to do a check on ratios. So I say 2 divided by 1. 2 divided by 1 is 2. Then this one's 4 divided by 2, and that's 2. And this one's 8 divided by 4, and that's 2. And this is 16 divided by 8, and that's also 2. So see, all the ratio of my first differences, it's all 2. That makes this an exponential function. Okay? If I go back here, that's what this means. I cannot do the ratio on the y values. I got to do the ratio on my first differences in case my function does not start at 1. Okay. This point's not all that interesting. I'll let you read it. This is the other part that's important. Graph of exponential functions can be decaying. Those are the ones that kind of start big and go down, or growing, exponential growth, that it goes flat and then it gets steeper and steeper going up. Okay, which one's good, which one's bad? That doesn't really make any sense. It's what the situation is, and we got to use it. All right, this is getting kind of long. So here's going to be what the handout's going to look like. I need you guys to answer these questions and check where things are. I'm going to show you a little bit of, you don't have to do these questions. I'm going to show you a little bit of the first questions. So if I was saying employee earns $25, then gets a $1 raise, then $2 raise, and $3 raise. So that would be 25, then he gets a $1 raise, that's 26, he gets $2 raise, 28, then $3 raise, that's going to be 31. Do it like that, and then please go ahead and figure out if this is linear, exponential, quadratic, and you do that by checking the first differences and the second differences. If the first differences are all the same, obviously that's linear. If the second differences are all the same, then that's quadratic. And if you check that the ratio of the first differences is constant, it's a constant ratio, then that would be the exponential one. All right, hopefully that makes a lot of sense. Can I show this to the second for the cup of coffee? And these are the other 3 questions that are left. Again, you don't have to do this part, just get those 5 questions. They're going to be a little bit more intense than the usual, but I think it'd be worth your while.